Unit 2.1 is brought to you by Leo Imperial Soldier, I guess, with colors. So, Chapter 2, or Unit 2, is the algebra-heavy type of stuff that we're going to do. However, we're going to do most of it with the use of graphing calculators, primarily Desmos. So this first unit, this first lesson, lesson 1 in Unit 2, we're going to look at some real basic things, ways to identify between linear and exponential growth. And this entire unit is focused on just these two types of functions. So let's start with looking at some patterns. So here we're just going to look at the numbers and predict the next three patterns. So if you notice, we go 3, 6, 9, 12. We're adding 3 each step. So that means this would be 15, 18, 21. Well, then the next one, we see 3, 6. So that could be, same start as before, right? Multiplication, addition, 3, 6, 12, 24. We're not adding 3 each time. From 6 to 12, we added 6. From 12 to 24, we added 12. But another way to look at this is we're multiplying the previous number by 2 to get the next one. So this next one would be 48, or 24 plus 24, and then 96, and then, let's see, 96 times 2, let's see, 6 times 2 is 2, 192. Okay, now the next one, we've got decreasing numbers, so 320, 160, 80, 40. To me, this looks like we're cutting these numbers in half. So 320 divided by 2 is 160, 160 divided by 2 is 80, 80 divided by 2 is 40, so then it would be 20, 10, and 5. Whereas the next one, which starts with 320, it then goes to 240, then 160, then 80. Let's try a little test here. What is 240 minus 320? Oh boy. It looks like 80, doesn't it? Minus 80. And then let's see, 160 minus 240. That also appears to be minus 80. And then 160 minus 80 is 80. So we're subtracting 80 each step. So 80 minus 80 is 0, and then we get negative 80 and negative 160. I'm not quite as good with the letters, but if you write out the alphabet, A, B, C, D, E, F, G, you can see that we're skipping every 2 letters. H, I, J, K, L, M. Oh, there's the next one. N, O, P. Oh, there's the next one. Q, R, S. It'd be really embarrassing if I messed this up. All right, then we see 1B, 3D, 5F. So it looks like we're following the same, excuse me, a similar pattern, only we're skipping 1 letter. So A, B, C, D, 5 is in for the E, F. So, and then we're going by 2, 1 to 3, 3 to 5. So this next one should probably be 7. And then skip the G, so we should have H, and then 9. Now this last one, or this number 7, is a very famous sequence of numbers. And my daughters were watching Odd Squad the other night, and they had it on Odd Squad. This is called the Fibonacci sequence. And what it does is you have 2 starting values, and then you add the 2 numbers together to get the next one. So 1 plus 1 is 2. Then we add these 2 together. 2 plus 3 is 5. Then we add these 2 together. 3 plus 5 is 8. And you add these 2 together. 5 plus 8 is 13. So our next one would be 8 plus 13, which is 21. And then 21 plus 13 would be 34. And then 21 plus 34 is 55. Check that out, Fibonacci sequence. You should Google that. It's a pretty cool sequence that actually shows up in all kinds of natural things in the world. All right, last one. I had to look this one up, I'll be honest with you, for what the author was thinking. There are, I mean, you could look at the pattern as JFMA, M, so then it could be that this is just being repeated over and over and over. But if you think about the months of a year, January, February, March, April, May, June, July, August, September, that's what the author was thinking about. So what we've just done here is we've looked at a sequence of numbers and looked for patterns. And in this first one, we were added the same number each time. Then we were multiplying by the same number. Here we were multiplying by the same number, but it happened to be a fraction, so you could think of dividing. Here we were subtracting the same number, and then here we were just kind of noting potential patterns that were going on.